you've got plenty of components. You've got, you know, many principles and techniques and algorithms. And if you don't understand them, the picture might look like this. But if you happen to be an expert, then you can, you know, build an engine, throw that into a car, and you can drive such a complex machine using 2 pedals. You can use, you know, a brake and a gas pedal. And you're moving a very complex machine. So the same way our engine has to move big data, and it has to move truly big data, and also not so big data. So I'm gonna demo our web application, but before doing so, I want to introduce 4 important concepts that are used in our application, and you probably all know this, but I just want to make sure we're all on the same track. And we call a source, you know, the data that you upload or stream to us, and that data can be saved and formatted to get useful analytics, and that's what we call a data set. And that can be turned into something actionable and clickable, and that's what we call a model. And you can input us new data, and we'll give you immediate predictions. So I'm going to switch my screen now, and I'll show you the website. There it is. As we're having some connectivity issues, I'm already logged in because the DNS is doing weird things. And here you can see the main dashboard of BigML. And as you can see there in the menu, we've got these resources I've told you about, the sources, the data set, model, predictions, and tasks. Well, I haven't said anything about tasks, but it's a simple one. And sources, I'm not going to load a file and start it. We've got some sources loaded and data sets generated and models because it takes time. And I'm going to show you some of the details. And here you can see the sources that have been uploaded to the website. We can click on one of these, for example, and we can get details of the source. And what we're doing here is we're trying to do we do a best match for parsing the source you gave us and draw a table in which you can see the attributes of the source you passed to us and the data you have. And this is a preview. Actually, you've got a button here in which you can play with some configuration options for generating data set. And out of this data set, out of the source, we've got a data set generated. And it's this one. I think I was showing cover. Well, it doesn't really mind. You probably all know the adult CSV file. And if we look at the data set, we generate histograms. And we give you some statistical information like the minimum, the maximum, the average. And you can move over the histograms and get information in nice tooltips. And this has been generated with our parameter-free option. We've got something we call the one-click data set. You can generate one source out of, you can generate a data set out of a source with just one single click. And out of this data set that you can see here, we've generated a model. And if we look into the model, well, connection is a little slow. Hopefully it works.
So can you tell us what's in the data set quickly?
In the data set?
Yeah.
Well, you've got, I'm going to go over that now. So the data set is mainly statistical information and histograms for the source you've uploaded to the website.
What's adult CSV?
Adult CSV is a famous CSV file that gathers information for census data of people and tries to classify those people into 2 groups: the people that make more than 50K a year and people that make less than 50K a year. So it's a famous CSV file, and it's online. You can get it. It's like the hello world of machine learning. And this is the model we've generated for this data set. And you can look at it, and as you can see, we're working on the visualization of the models, and we're putting a lot of detail into this because we want new people that not so experts in machine learning to understand the concept of model. And here we're using Rangel-Tilford layout algorithm that makes it more aesthetic, and it's less width, so it fits in the screen. And if you see the widths of the edges between the branches, they're different, and they represent the proportion of training data used in that path. And we're using a smart color schema to color the most common nodes in a way that makes sense. And we can go over some of these paths. I'll go over one of these, for example. And on the right side, because we don't want the screen to be messy, we're explaining what's going on in the path you selected, and we're telling you that in this case, in this path, the classification is this one, and you're going to be getting a person that has an income of less than 50K. And also, we're doing right now binary trees, but in the future we'll do different trees too. And on the top, you get the prediction too. And I'm not going to be showing the predictions forms and all. But we're working on this. We're working on different ways you can ask us for predictions. And what I'm going to be showing now is the API. We are working on an API here. It's a RESTful API, and we're formatting all our data in JSON. So what I'm going to be doing is I'm going to create a source. What? Oh, sure. Sorry. Up. Can you see it now? More? Sorry. Better. Okay, so what I'm doing here, I'm demonstrating the API, and for that we're using an Irish CSV file, also a very known CSV file or data source in the machine learning world, and that has created a source in my account, so I could go here in the sources, and as you can see, 0 minutes ago, so right now I've loaded this file to the system, and we can now go in, sorry about that, this is not the right. We can go now and create a data set, picking the resource that was passed here. If we go and pick these here and paste it here, this is going to be, we're now generated the data set. Well, right now we're processing it and generating, as it is a small file, it takes very little time to be done. And here it is. We can look into it, and the histograms are built. And I'm now going to create a model for that, so you can see how it works. And I'll grab the data set here and paste it. And we're requesting our API now for creating a model, and it's giving us some information. An interesting thing of the API is that we are passing a lot of data, and we're building a very extended API that lets you build a lot of things on top of us. And it will see it's already here, the model. We can look at it, and here is the representation of the tree for that model, and it's classifying types, species of flowers. And also, we could go and create a prediction for that model. We just need to say what model we're using. Sorry about that, miss a C. We're going to pass an empty query. And there it is. It's saying we'll get an Iris virginica flower species. So I'll continue with the presentation now. How we're doing this. I've shown you the website. I've shown you how we're doing the API, and I want to talk about some of the details behind it. Our website is going to be on bigml.com. It's already there. You can go on the website, and actually we've launched today the new landing page, and we're going to be starting our alpha testing site before the end of the year. And the API is going to be BigML.io. Of course, we've built this on top of the cloud. We're now using Amazon Web Services. And as this is a machine learning conference, it's better if we talk about the details behind some of these histograms. And we're using a streaming approximate histogram algorithm, Benheim. This let us build a memory constrained summarization of our data source in one single pass. And this implies scalability. And we can actually work on independent samples of the data and turn that into a parallelizable algorithm. And of course, the number of beans you use for the histograms determines the looseness of the compression. The more beans you use, the less loss you have in the compression. And there is a trade-off between CPU, memory, and time consumed for doing that. And our standard histograms got information of the objective fields within the data set. And that way, when we start computing our histograms, we need to pass the full data set just once in the beginning. Also, a graph now that explains better. And we're using, of course, histograms for finding the approximate best splits when growing our trees. And the way it works is that the master node communicates to the workers the full data set. And then the workers start calculating the histogram, but first in the step 2, they need to get the current state of the tree. In step 3, they start calculating the data sets, the histograms, sorry. And when they're done, they communicate it back to the master node in step 4, and the master node merges these results and finds the best split and grows the next generation of the tree. And after that, it communicates the new current state of the tree back to the worker nodes, and we start again. And the way we're doing distributed trees is we're using Storm. And we're using Storm because, as you probably know, machine learning algorithms are iterative, and it's being talked right now that Hadoop MapReduce strategies don't really match some of these algorithms. And with Storm, we can lay out our own topology and choose the degree of parallelization we have, and also state in the nodes when we're in the process. And if the data sets are shuffled, we can do an early split, which means that the master node, when the master node can request a partial result to the worker nodes for histograms. And if those histograms are similar, we do an early split, and that speeds up things a lot. And our testing shows that in the early stage of building the tree, it works really well. And so you might be wondering why trees. And the reason behind we're using trees is that we find them approachable and they're easy to visualize. So if we're trying to make machine learning easy for everyone, we need something, a representation people can understand, a representation people can grok. And we're now working on the classification and regression field. We're not doing ranking algorithms, we're not doing time series, we're not doing anything of that. And as we grow the tree breadth first, we have anytime algorithms. That means that we can grow the model while it's being computed, and that you can also request as predictions even if the model is not finished. So building all this has a lot of challenges, of course. And first one might be that we have a distributed network of clients that are working with us, and we need to be reliable. But the probably the most important one is to make big things go fast. And if we come back to the previous example I put about the cars and engines, fast cars are sport cars, and they have fast engines. But in a sport car, you have a little trunk, and you can barely fit anything into it. So what we need to build is something that has a fast engine as a sport car, but that can move big things as a truck. That means doing the elephant run as fast as a horse, or even faster. And we want all of this to be as easy as pulling a switch. And how do we measure easiness? Well, You probably have seen this before when you have, several remotes in your home and they all look alike. You end up not knowing which one is for what, and there's so many buttons and it's very complex, and you look like this, like, whoa, what am I going to do now? And well, you end up doing things like this. You simplify your remote. You can even put notes on the paper, and now it's super simple. You have a power button and a volume and channels. Simple. But what happens if something goes wrong? You've covered all these buttons that they're there for a reason, but you don't have them anymore. And we want to build something easy, but we want you to have the power to do stuff on it. And that means that following our driving example, the amateur driver and the professional drivers both use a card, but they don't drive the same way. And here we're gonna have people new to the world of machine learning, and also professional experts on this field, and we need them to have power, and we're trying to build an interface that works more like a sidekick, that you can hide and unhide advanced features depending on what you're looking for, and this way you can tune up how you're building your models and your data sets. And we don't want our users to stare at the screen and knowing what's going on, what the data means, what is this for. So that's why we're using infographics. We're using a representation of the data that people are familiar with. And we don't want people to have infinite steps. And with this, I mean those web applications that have forms that they are always telling you, you're about to finish. And then they pop up saying, oh, there's another step you have to fill. Now, we want things to be simple, and that's why we created things like one-click model, which means that you can create a model out of a source with one single click, and that's amazing. We think that's amazing. And of course, also we have to do an API, and as I've shown you, we're building an API in which you can rely and build stuff on top of us, and that way you can integrate with us, create a new project, and hopefully we'll have happy customers. So what's the future of BigML? Well, as I've said, we're going to be throwing the alpha version. We're going to be launching alpha version before the end of the year. So if you want to join us, I recommend you go into the website and leave us your email. And of course, we're trying always to do better. But doing better means even working more on the interface, trying to make it more intuitive, so people don't get lost. And that's going to take us, it's going to take us some time and polishing details. And we want to be faster. We will always look for being faster. And at the same time, we want our predictions to be more precise. And we don't want this project to become a black box. In the sense of the engine, we want you to have control of the parameters and control of the tune-up of the engine. And in the end, we are looking for building what we call a marketplace. And this would mean that you could have your data sets and models with us, make them public if you want, and share them with the world, and get a part of the benefits we get of the use of those data sets and models. And well, this is it. Of course, we're hiring, so if you're interested, you can get in contact with us. I've brought some t-shirts with me, so I'm going to be giving one t-shirt per question, per person, till I run out of them. Okay, so this is it. Great.
Why is it amazing to build a model with one click?
Because right now it takes a lot of effort and a lot of knowledge to do the same thing with other set of products or applications. And what people in the industry world look for, or in the business world look for, is to get predictions. You don't want the hassle of all these. You just want precise predictions in which you can rely. Does that answer the question? Okay.
Thank you for the presentation. I have a question about the data. So the assumption is that the data is transferred to the cloud in order to be able to do the analysis. Because we're talking about hundreds, thousands of terabytes of data. How are you going to?
Well, we're going to be handling this in with two different systems. We're going to have URLs you can post to. You can stream your data to us, and also you're going to be able to upload big files. And for the streaming part, it pretty much solves the big data part. Like you could be also streaming real-time data with us. Well, I don't know all the details, but yes, we're going to be, of course, charging for the use of the service. We're still discussing some of these points, but there will be charges for some things, and we've got a credit system working now, but we don't have fixed prices yet. Well, we aim to have any kind of user, which is a hard task, of course, I know. But our typical user would be, I guess, because it's a hard question, somebody interested in predicting, that's very generic, but for example, somebody in the marketing world that needs to extract information about the data they have, or somebody in the technical department of a company, I don't know. No, we're being realistic with this, and we are doing very complex heuristics for finding out, how your data is laid out, and also if we don't happen to find a good match, you've got the options there to tell us this is why you're wrong, and we will try to improve from the user experience. So we'll try to also learn from the way that we're failing at analyzing the data.
So how do you handle missing data? If, because it's rare that it's perfect, how do you clean data?
Well, the source I showed, it's not perfect actually. It's got some columns that are empty. So we put a token there that no value, and you can actually tell us what no value means or what token to use. And if there is a lot of data missing and it doesn't make sense, then we're going to request you to manually operate the file.
One of the difficulties in the company is just to extract the data and find which data to extract. Do you offer some help on that side for companies who don't have that expertise?
No, at the moment we're not looking into that, into having like support system for extracting data or that.
From what I see from your presentation, it appears to have only one type of model. Is it the case, or are
One type of what? Sorry?
one type of model?
We now work with binary trees, as I said. But it's not here, it's not released but we are actually now working with other trees.
Okay, but you only have trees?
For now, we'll have trees, but
You plan to have more?
we'll probably have more things in the future.
Can we talk about online models more? So I submit data, I build a model, and I would want to update it somewhere in the future.
Sure.
Plan or
Yes, we're planning that, and at the moment, what you have to do is actually re-upload. Like, for example, if your data changed, you will have to re-upload the whole data again. But we're now working on that, and we're planning because we know many people have requested that, and have people that we talk with and tell us to get this into account. Like my data changes. Of course, data changes all the time. There are, of course. We've got competitors, and I guess in the startup world, the one that thinks that doesn't have competitors is a fool. And what I guess, the key here is the execution of the idea, and this is something everyone says all the time, but we're trying to build a different product. We're not trying to build the competitor's product, and some of those competitors work for very specific things. They work, for example, on analyzing text or time series, but we want to be more wide spec. I didn't hear the last part. Well, I guess this is my personal opinion, okay? I'm not saying everyone is going to understand this. Not everyone understands everything. But we've shown, this to people that are not in the field, and they really understand what we're doing, and they are very interested into seeing more. And they get interested into the machine learning world, which looks like now, from the outside world, looks very scientific, very, very technical and not very practical. So people get afraid of it.
We'll do one more. Can you elaborate on the reasons you chose Storm?
Well, I'm going to ask you to forward, if you have any question, to Charles. Charles is the person in charge of the Storm part. I think there's a talk today here about, between the difference between Hadoop and Storm for machine learning algorithms, which is going to go very into detail. But I've said what I know, basically. This is not my field.
Thank you, Miguel, again. Kama Kruger is up next, talking about fast cross-validation.
So come and grab your T-shirt if you ask a question. Yeah, hold on a second.